So here we are in the Synopsys booth at the Embedded Vision Summit. We have multiple demos for our Embedded Vision Processor IP, the EV6X. Now, the trend for CNN demos is toward more efficiency for the same amount of accuracy. So the demo we're showing is MobileNet. But there is also a trend to higher levels of performance needed. If you go from a 1 megapixel camera to an 8 megapixel camera, you're going to need more performance. So the question is, how do you scale up to those higher levels of performance? And can you take a CNN graph and scale it across larger numbers of multiply accumulates? So on our FPGA platform, using 880 multiply accumulates, we can get 3.4, 3.5 frames per second using this number of multiply accumulates. Now, it would run significantly faster in an actual chip, but this is a development platform. So if we double the number of multiply accumulates from 880 to 1760, we should see, best case, a doubling of the speed. 1.9 to 2.0 speed up, exactly what we would want. 2.0 is ideal, and 6.6 frames per second. Again, based on the FPGA speeds. So again, if we double the number of CNNs, can we scale the graph across a larger number of CNNs to improve the performance? So we'll go from 1760 to 3520. Here we have 3520, 3.67 speed up at 12.3 frames per second. So you can see the improvement in performance and only a little bit of efficiency loss due to bandwidth in the system. Fundamentally, what happens is you get to more and more multiply accumulates. The problem is not the performance, the problem is the bandwidth. So now you have to get all this data in and out of your processor, and you've got some DDR limitations. So there's many things we can do. Obviously, the DDR in this system is a limitation. In your design, you might have more compression built in, you might have more DDRs built in, or with many of our customers, we're limited to the DDR setup they have, and then we work on improving the performance of the algorithms and the efficiency of the graphs. So again, in this demo, you can scale up. We can scale past 3520. We see needs in automotive for significantly higher amounts of capability of CNNs. If you want to know more about the EV6X, come visit us at thesynopsys.com/EV. Thank you.